Okay, so this is our problem. Solve tan squared theta minus 2 tan theta minus 10 equals 0. Okay, well, looking at that, I can see the factors of minus 10 that get me close to 2 don't work. So 2 and 5 will give me 3. So I need to use the formula. So my formula for theta, well, for tan theta rather, because tan theta is a variable, is given by minus b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to substitute. B is minus 2, so minus 2 plus or minus the square root of minus 2 squared minus 4. A is 1 and C is minus 10. All divided by 2a, which is 1. Okay, simplify. Minus minus 2 is 2, plus or minus the square root of minus 2 squared, 4 minus 4 and minus 10. So that's going to give me a positive. 4 times 10, 40. All divided by 2. Okay. So that's 2 plus or minus the square root of 44 divided by 2. So that's tan theta, giving me two answers. So you got 2 plus the square root of 44 over 2, or 2 minus the square root of 44 over 2. Well, we put those in our calculator for tan theta, and we get 4.3166 or minus 2.3166. So those are my two answers. Now I've got to find theta. Theta is equal to the inverse tan of 4.3166 or the inverse tan of minus 2.3166. Plug those in my calculator and I get two solutions. I get theta equals 76.95 or minus 66.65. Okay, so I've got those two solutions. This is the only one that lies in the range from 0 to 360. However, there might be other values. What I need to do is sketch the curve and draw the line. Now with tan, we don't always sketch the curve because we know it repeats every 180 degrees. So I could simply add 180 to this, which would give me 256.95, which is still in the solution, so that would work as well. And then everything else would be too big. Here, it's giving me a negative answer. So if I add 180 on, it'll give me a positive answer. And then add another 180. Now we can see that if we sketch the graph, it's not such a simple one to sketch on here. See if I can use a line instead. Might help. Not convinced. So it's 0 to 360. Okay. So, tan curve, like so. It's asymptotic at 90 there. That's 0. There's your y and there's your theta. And that's 90. Then we go again, and because it repeats every 180 degrees, that's 180. And it's asymptotic then at 270. And it repeats again every 180. And we stop here at 360 degrees. Okay, so the solutions we've got, let's plot them on. I've got 4.3166 gives me 76.95. Let's do that in green just to show the additional solutions. where's my green pen? Okay, so if we said 4.61 is here, I tell you what, if we use a straight line, it's much easier. There we go. So that's 4.3166. Let's give me a solution there. That solution is the one we got off the calculator. That was 76.95. Then it repeats every 180 degrees. So I add 180 on. So this solution is going to be 76.95 plus 180, which is equal to 256.95. So that's how you get all the solutions. Then we do the same thing for the negative value. So as we said before, this is why you don't need to actually sketch the curve, because for tan it repeats every 180 degrees, whereas for sine you need to repeat it. You need to draw the curve. This is minus 2.3166, and that's the solution you got on the calculator there, minus 66.65. Then you add 180 to get the next solution there, which is minus 66.65 plus 180, and that's equal to 113.35. I'll just tidy that up, it's a bit messy. So we had minus 66.65 plus 180. That gives you the second answer. But we've got another solution here that falls within the range. It's not up to 360. So again, we go on to there and we add 180 on. So 113.35 plus 180, and that gives me 295.35. So we can write, when theta equals 76.95, we also get the solutions 256.95, and where theta is equal to minus 66.65, we also get the solutions of 113.35 and 295.35. All we're doing is just adding 180. Now this solution here doesn't fall in the within the range, so we can cross it out. But the others all fall within the range. Okay, same thing here, that's plus 180. So you can plus or minus 180 to make sure you fall within the range. Good, hope you understand that. Any more questions, let me know.